filming? Okay. All right. So this is take one. Should I look at you or look at the camera? Which one looks better?
Probably look at the camera for a second, and then look at me. It looks almost the exact same.
All right. So this is take one at the fire analogy of life. Let's call the video. All right. Something like that. All right. So this is just me explaining, framing up an analogy that hopefully gives the viewer a clearer understanding of how I see life. And that doesn't mean life as in my life, but the phenomena of life, biochemistry. Why are we making this video? Good question. So Amelia has been, that's your cameraman, Amelia. Some of you all have met this person. She has been encouraging us, to make some videos of me running my mouth. So I can blame Amelia for this video. So let's get into it here before this thing gets to be 30 minutes long. I want to keep it concise. And if you make it to the end of this video, and I think that'll probably be about 5 people, and you know who you are, give me some feedback and let me know how accessible this is and how eloquently I explain this or cumbersomely I explain it. I'm all ears when it comes to getting feedback. That's why we're making this video. Okay, here we go. Fire analogy of life. So first we need to talk about the origins of life. This video is predicated on the idea that Darwinian evolution, while not a totally watertight theory, there's holes in it. There's holes in all scientific theories. It's good enough to produce a pretty sound worldview. So we're assuming that Darwinian evolution is right enough. Okay? All right. Make sense? Okay. So I don't want to hear any like, well, Darwinian evolution isn't quite accurate. Right. So we're not doing, this isn't a discussion about whether or not evolution is a thing. It's a thing. Here we go. So about 4 billion years ago, life emerged on Earth. The biochemical phenomena we call life. It emerged on something called an alkaline hydrothermal vent. Let me show you a picture of a hydrothermal vent. Can you see it?
Mm-hmm. You can move it a little closer.
It's like a little tiny volcano under the ocean. Okay, so that's a hydrothermal vent. Alkaline hydrothermal vents are now extinct, but there used to be alkaline hydrothermal vents. But as far as you're concerned and I'm concerned, it's a hydrothermal vent. So life, biochemistry, took root, was produced by, it was an outgrowth of an alkaline hydrothermal vent. In time, this biochemical reaction became anti-fragile, resilient, robust enough that it was able to relinquish the alkaline hydrothermal vent and float off into the ocean. It became an autopoietic phenomenon, something that is distinctly life. And I think it's safe to say that we are all descendants of that cell, that individual cell. I am this cell talking to itself. You're the cell listening to it talk. It's all the same cell, okay? So life emerged from a place in space and time and then radiated out from that point to fill all the surface on Earth. All right? That's what happened. So we're going to use fire as an analogy to frame up what I think is the most important point that a human being can grasp. What I believe. And I think that if we don't understand this point, we're going to go extinct, or we're going to keep going extinct, because we're kind of extincting everything right now. And that will keep happening if people don't get this point. A lot of people do get this point. I'm not saying that I'm alone in this, or that I even particularly get this point that well, but I'm talking about it right now, and I think it's very important, which is why I'm talking about it. So, fire analogy of life. Here we go. All right, so let's pretend that I'm starting a friction fire. This is the alkaline hydrothermal vent, all right? I'm starting a friction fire. This is the spindle. This is the fireboard. I think those are the actual terms for these implements. I have started a friction fire. If you've never done it, you should. It's one of those things. It's like seeing an eclipse. You have to do it before you die. All right, here we go. I'm starting a friction fire. Can you see the apparatus? Mm-hmm. Okay. All right, so if I do this, if this was a real fire kit, right, I would do this for something like 30 seconds or a minute, and I would start to smell certain smells emanating from the fire kit. And in time, I would start to see smoke. Okay? So think about the first inklings of biochemistry on the alkaline hydrothermal vent that we came from. There must have been a moment, that moment being maybe decades, centuries, I don't know, months, I don't know. But there was some period where there was something kind of like biochemistry happening. But if we could take biologists and put them in a time machine and bring them back to that place, they might look at it and some of them would be like, well, that's not biochemistry, and one of them might be like, I think it is biochemistry, right? So keeping that in mind, we're continuing to apply pressure, make heat. Now there's a lot of smoke. In time, there is some ember glowing, okay? There's an ember, okay? Maybe, so the analogy with the alkaline hydrothermal vent is now we're getting closer to life. We're almost life, okay? So there's this in between. It's really starting to look a lot like life, but if we had 100 biochemists or 100 evolutionary biologists, only 9 out of 10 would be like, yeah, that's life. Okay, so now we have an ember. We're fanning it. We're blowing on it. And then we get, can you see this? Is this in the frame?
Move it back
okay.
towards you.
All right, we get fire. We have fire. We can all agree this is fire. The ember wasn't quite fire. The smoke wasn't fire, but it wasn't totally not fire, right? So there's this continuum of phenomena that then becomes something that we have a word for called fire. This is fire. Everyone agrees this is fire. The alkaline hydrothermal vent, after some years, decades, centuries, millennia, I don't know, gave rise to something that 10 out of 10 biologists would point to and say, that is life. But there was this continuum of phenomena leading up to a moment where there was a consensus. This is life. Okay, so, make sense so far? Yes? Here's life. Here's fire. All right? Okay, we distinctly have some fire. This is a cell. All right? Cells split. Mitosis is what that's called. They split. They make more of themselves. Okay? Here's the cell making more of itself. Okay, we have fire occupying different points, different regions, locus of space. Different regions of space. But it's still just fire. I don't see these, this is the crux point here. I don't see this as fires. This is a phenomena called fire happening in various points in space. So I don't believe in the concept of fires. There is a phenomena called fire. We have a word for it. It's called fire. It's distinct. We can agree on what it is. It can happen in different places. It can consume different substrates. It can be different colors. Each region of fire is non-fungible and unique, but not separate. All right? That's the really important part. Okay, so you think about life. It's evolved on this vent. It's leaving the vent, and it's splitting into multiple cells. Are those cells separate? They're distinct, but they're the same thing. Okay? It's the same stuff. It's the same phenomena. It's made of the same substrate, but it's starting to spread out into space. It's moving through time and spreading out into space, but it's still the same chemical reaction. It's not a new chemical reaction. There's not a break, a new cell, a break, a new cell. It's a continuum, right? And that continuum has continued long enough that we have speciation. The species aren't, look, I just caused an extinction event. So the
Uh,
so species are just, you could look at them as candles that have, traits, qualities that are so unique, and the patterns of that uniqueness are stable enough throughout time that you can say there's a pattern there. There's a distinct pattern here. So a species isn't a thing, but it's more like a pattern. It's a tendency, right? It's a spatio-temporal locus in a biochemical reaction that's 4 billion years old. Okay. Same with individuals. All right. So this is a flame. That's a flame. You, the viewer, flame. It's all fire. It's a continuum of the same process. It's not separate, but it is diverse, and there are distinctions, right? But it's not separate. So you, as an individual, are a non-fungible, unique, distinct region of a 4 billion year old biochemical reaction. Your qualities that make you have never existed. They will never exist again in the future. You are happening now, never happened before, you'll never happen again. You're not a thing, but you do have completely unique, non-fungible characteristics. And I'm of the opinion that it is your obligation to exercise those qualities towards the betterment of the world, to serve beauty. Right? That's my opinion. That's why we're here. Okay, what about this doesn't make sense? The key point here is that there aren't lives, and there aren't individuals. There is life. There just is a phenomenon called life, just like there's a phenomenon called fire, occupying space, moving through space, and continuing through time, like an accordion, stretching through time, unbroken. Right? It is diverse. It is unique all throughout itself. It has non-fungible characteristics and qualities all throughout itself, but that does not imply separateness. Right?
Yeah.
Okay. That's the point. Right? Are we done?